Okay, you're able to see the PPT right now?
Yes, sir.
Okay, thank you. So very good morning to all of you, my dear boys. Okay, so
Good morning, sir.
very good morning to all of you. Okay, we'll start with the data networks, the basics of data networks. It is third and fourth unit. We have this data networks only. Okay, how data is transmitted between various devices. What are the fundamentals of data networks, and how networks are configured. We are going to see some of the basics of data communication, and then the networking, how devices are networked, the fundamentals, what are the interfaces by which devices are connected. Okay, we'll start with the basics of data communication. First, the communication. Okay, we need to know about what is communication. Communication is nothing but two devices. If they wanted to communicate, they need a medium for transmitting signal. Okay, if it is human communication, we need to have free space as a transmission medium where a person can talk to another person. Okay, only the other person can understand the language, so he'll be able to communicate in an effective way. Similarly, if devices they want to communicate, there should be a proper medium, and devices they communicate with the digital languages, binary ones and zeros, or even if it is analog signal, accordingly they need to be converted into a form that will be transmitted over the transmission medium. Okay, so the transmission of a signal by way of medium from a sender to receiver. Okay, that is called as communication. And in this you get some noise.
Jenny se mute pandradi.
Okay. Okay. So that is communication, the transmission of voice or data from transmitter to receiver with the help of a transmission medium. Okay. Next is what are the various benefits of communication? Okay. Benefits of communication. Nowadays the devices are able to communicate, and so we are able to have these benefits such as email, voicemail, fax, teleconferencing, and it also improves the workflow and simultaneous access of data. Okay, so these are some of the basic benefits of data communication. So file transfer, distributed databases are some of the key benefits or advantages of communication. Okay, next we are coming to the core of data transfer. Actually, in devices there are two important techniques by which data are communicated. One is parallel transmission and the other one is serial transmission. Okay, so in parallel transmission, multiple wires will be used to transmit more information. Okay, simultaneously 8 bits or 16 bits can be transmitted at the same time. Within a short distance, if you want to communicate, it is mostly parallel communication within the board or within the circuit blocks. If communication is going to take place, then it is called as parallel communication. For example, when you have a processor, inside the processor you will have many functional blocks, and the communication is going to take place between the various functional blocks. It will be parallel communication only. Okay, with the help of buses. Buses are conducting lines which are going to communicate between the various functional blocks. But serial communication is if you want to access to a remote location, or if you want to send a control information to a remote location, then we go for serial type of transmission. Okay, that is only 1 bit at a time. serially or sequentially bits will be transmitted, and it is slower but can be used for longer distances. Examples for these type of serial communications are RS-232 communication cable, RS-485 communication cable, and all they use this serial mode of communication, okay, where only a single pair of wire will be used for transmitting the signal, okay. So you should know the basic difference between parallel and serial communication. Parallel multiple buses will be used for carrying many bits at the same time. Serial communication, one wire along with ground will be used for transmitting the signals to longer distances, okay. So the diagram, how in parallel transmission occurs, that's a basic schematic of how 8 bits are transmitted simultaneously. You can see 8 wires are used for simultaneous transmission of 8 bits. Okay, in this type of parallel transmission, there is a possibility that there may be interference between the wires which are adjacent to each other, which is called as now interference or crosstalk may occur in parallel transmission, okay, because when there are multiple wires and if the signals are transmitted adjacent to each other, there may be possibility of interference may also take place, okay. Understood, boys? What is interference? Hello?
Yes, sir.
Okay. So whereas communication, it is only bit by bit transmission, okay. So sequentially or serially, 1 by 1 bit will be transmitted. So this is an example of how serial bits are transmitted, okay. So you use only one wire and the bits are transmitted sequentially or serially, 1 by 1 by 1, okay. So this is called as serial transmission, okay. And in serial transmission also we have classifications such as synchronous transmission and asynchronous transmission. What is synchronous transmission is, see, every system they'll have a clock, okay, with which they will operate. And if they are going to use a system clock, both the transmitter and receiver, if they are going to use the same clock, then it is called as synchronous communication. But there are cases where one device will be faster and the other device will be slower, okay. For example, a processor will be operating at a high frequency and a slave device or a peripheral device may be operating at a lower frequency, okay. In that case, there will be speed mismatch will be there, and so the receiver has to wait for the transmitter to send the signal. Transmitter may be operating at a higher frequency, okay. So there will be gap between the speed at which the transmitter is sending the signal and the receiver is going to receive the signal. So for this type of communication, we need to have start and stop bits, asynchronous mode of communication, okay. So start and stop bits will be used in asynchronous communication to indicate when the data is going to start and when the data is going to end, okay. So that type of communication is called as asynchronous mode of communication. So we need to know what is synchronous, what is asynchronous, and what are the significance of start and stop bits, okay. Next, modes of data transfer, okay. So we need to know about what are the different types of modes of data transfer depending upon whether it is one way at a time or two-way, okay. So what is simplex communication is only one-way transmission, okay. Only you can transmit, that is, it is unidirectional, okay. The data can be only transmitted, the receiver cannot take part in, okay. That is called as simplex way of transmission. The next mode of data transfer is the half duplex communication, where communication can be from both ends but only one at a time, okay. Either it can transmit or it can receive, okay. So that is called as one way at a time, okay. walkie-talkie, police walkie-talkie, and all one way at a time only. Okay, and what is full duplex communication is, for example, voice communication. We need to have end-to-end connectivity. When we have end-to-end connectivity, we are able to establish two-way transmission. So dedicated link voice networks, they'll have end-to-end connectivity, and so people may converse each other, and so we are able to establish communication from both sides simultaneously. Data transmission and data reception can be possible. Okay, in the first case, in simplex communication, for example, if my keyboard wants to communicate to the processor, it is one way only. Keyboard can send a signal to the processor. Okay, it is one-way transmission, and the processor may not be able to respond to the signal the keyboard is transmitting. Okay, so these are some of the basic ways how data will be transmitted. Okay, depending upon one way at a time, and simultaneous transmission reception, we classify it as simplex communication, half duplex communication, and full duplex communication. Okay, understood, boys? What is simplex, half duplex, and full duplex? Hello?
Yes, sir.
Okay, thank you. Next is why we need to go for network. Okay, what is network is when terminals are connected in some configuration to share some data. The computers, if they are connected to each other so that they can communicate the data. Okay, that is called as a network. Okay, configurations by which network can be connected. And before networking, there was a technique called as sneaker net, where they were copying the information from a disk and they pass it to one whoever needs it. Okay, it's not a convenient method. A lot of security aspects need to be considered. So networking is very important in order to connect various terminals in a particular configuration. Okay, so we need to know about different types of configurations of the network. Then why we need to go for network? What is the necessity for network? A network is required basically for file transferring, sharing the applications, and also device sharing also can be achieved with the help of network. Okay, and the work activities, when there is a group of people working. Okay, so network helps to coordinate the work group activities, also helpful in scheduling, conferencing. These are all some of the reasons why we need to go for network. Okay, next, what are the components of a computer data network? Okay, we need to know about what is a data network. The computer data network will have three important components. First one is the hardware. The hardware part of computer network will have the computer terminals. It can be server, clients, routers, modems, modulator and demodulators, network interface cards. These are all some of the hardware components present in computer network. And the software part of a computer network is you have the network operating system. Operating system is a supervisory software which helps to share the resources to the other client terminals. And the communication software. The communication software helps to share the files. So software part of a computer network is very important in order to utilize the resources as well as sharing of the resources. Then the important interface, the channels which are used to communicate various devices. The communication channels can be wired as well as wireless. Okay, there are various types of wired channels such as twisted pair wire, shielded twisted pair wire, unshielded twisted pair wire, microwave links, which are wireless links, can be used for connecting various terminals. Okay, so a computer network will have various types of modules such as hardware, software, and communication channels. Then, based on the geographical location, the networks can be classified as local area network and wide area network. Okay, in local area network, a group of terminals can be connected within a specific location, geographical location. Then it is called as a local area network. And what is wide area network is? A wide area network will cover a larger geographical area. It may cover many cities and or computers which are connected across a country can be called as a wide area network. Okay, internet is an example for a wide area network. Okay, so we need to know about what are the different types of networks. Then a peer-to-peer network. What is a peer-to-peer network is? If the network size is very limited, if it is very less, there is no need for a coordinating element. Okay, so there is no need for any centralized communication device. So each terminal can act as a client or server. So these types of peer-to-peer networks, they have characteristics such as they're very inexpensive in nature and they have limited security and they use only their own resources. So they are called as the peer-to-peer network or work groups. Then other type of network is the server-based type of network. Okay, what is server-based is there will be a server which will be giving service to the clients connected to it. The service can be application, it can be a file transfer to the terminals which request for the service. So they have centralized control equipment. So they can share some of the resources to the client whenever they request for. And it has high security, it has high good backup also, and many users. It supports many users. This type of network is called as server-based networks. Next is how the applications and databases they are going to present in a server, and based on the request from the client, how they are able to serve. So applications and databases, they'll be present in the host computer, which is called as the server, and the user interacts with the application with no processing power. So this is how the host computer will act as a server to give services to other client terminals. Boys, able to understand what is server-based network? Hello? Hello, boys?
Yes, sir.
Okay, thank you. So this is an example of how a server is able to provide various services to the client. Okay, for example, the database will be residing on the host computer. The file server transfers the data and programs to PC on the network. Whenever the client requests for the service from the host computer, the files will be transferred. This is an example of how the client server model will work, and the server performs most of the processing. This is how through a common bus the terminals are connected. The client server terminals are connected using a common bus. Computer terminals, which can act as a server, they can communicate to the clients with, they share a common bus. This is a client server model, how the computers are able to communicate with each other. The client can request for a service and the server can give file access to the client. So how it works, the client server model, the client basically makes a request and the server fulfills the request. And once the request is confirmed from the client side, the server processes the request and it is transmitted. Once the requested information is returned to the client, the data will be transferred to the user. So in client server model, the network traffic can be minimized. Only the information required by the client will be transmitted. That is an advantage because it avoids traffic collision, traffic congestion in the network. So this type of model is called as a client server model. And next we need to know about various types of network terminologies. In computer networks or data networks, a workstation is nothing but a terminal connected to the network. It can be a server, okay, or a terminal or a client terminal. Each computer attached to the network is called as a workstation. And a node is nothing but it can be a router, it can be a switch, it can, any networking device attached to the network. That is called as a node. And each node, they will have a specific or unique hexadecimal medium access control address, MAC address, we call it as MAC address. They are unique in nature. Whenever you are connected to a network, it will assign a specific unique MAC address. And server is the database for information. And how these terminals are going to be connected. There are various configurations how the computer terminals are connected. It is called as topology or configuration. How we are going to connect the terminals in various configurations. Okay, so how we are going to connect various terminals, we call it as a network topology. So what a network topology means, for example, if there are n nodes and the number of cables which are required to connect this n nodes will be n into n minus 1 by 2. So we need to have that many number of cables to connect to n nodes. So a network topology is nothing but a model that describes how networks are structured or configured. And in data networks, there are various types of combinations how these terminals can be connected. And they are bus topology, star topology, and ring topology. You can see various types of network topologies, the ring topology, the bus topology, and the star topology. You can have a look at it, how terminals are connected in various types of configurations. So in a ring topology, the terminals which are connected are placed in a ring. Accordingly, token will be passed from one terminal to another terminal. In bus topology, the terminals are connected on a single bus and each device can communicate directly to all devices on the same bus. And star topology, the computers are connected using a central hub. And in hierarchical network, the terminals are arranged in a tree-like structure. So these are all the various topologies how the devices are connected. We need to know about various types of configurations, how the network topology, how the terminals are connected. The role of network communication software. What is the use of this communication software? Okay, because this network communication will be present as a software component. The purpose of this network communication software is to recognize the data as well as divide the data into various manageable parts, chunks, we call it as chunks.
Sir, what is meant by chunks, sir?
What is meant by
Chunks.
chunks? Means parts. If it is a larger data, it will be divided into small parts. With that, it is called as chunks. Okay. Suppose if you have a data which is a large segment of data, okay, and we need to divide that large segment of data into small segments. So that small segments are called as chunks. Understood? Hello?
Okay, sir. Okay, sir.
Okay. So we add information to each chunk of data to identify the receiver, because we need to know where the data is going to be transmitted, and so we add some control information. So each receiver will have a specific address. Transmitter also will have a specific in order to identify a transmitter or receiver, each will have a specific MAC address. Accordingly, we need to add some control information to the data so that it can be transmitted to the particular destination.
Sir, how these MAC addresses are created, sir?
The MAC addresses will be assigned in network layer. They see when devices are going to communicate, there will be a unique address which will be assigned for each device. When they are in the network, each device will have a specific medium access control address. Suppose if you are going to connect to a computer network, your device may have a physical name, but the computer
IP address.
IP address like that, computer can recognize only with the help of that IP address, which is called as MAC address. We call it as medium access control address. Okay. Accordingly, suppose if some information is going to be transmitted, only we know from which device it is transmitted. So with the help of that MAC address only, medium access control address only, we can identify the signal as come from this particular device. Okay. Then we need to know whether the data received is correct or not. Accordingly, from the transmitter, we need to have some timing as well as error checking information also will be added. Okay. For example, parity bits or error checking checksum also will be added in order to verify whether the data received is correct or not. So we add timing as well as error checking information also. And after adding this type of timing and error checking information, it will be transmitted to the network. Next is very important is the OSI model, Open System Interconnection Model. The syllabus you have very important this in CAT 2 as well as in end semester examination. you will find this OSI model, the functions of each and every layer in OSI model, how computers are going to communicate by means of a layered network architecture. Okay. This OSI model is a standard model by which the computers communicate with each other. This OSI model basically describes how the network hardware and the software work together in a layered function. Each layer provides some service or action so that it prepares the data for delivery over the network. The requests are passed from one layer to the next layer, and each layer will add information to data packet, which is called as data encapsulation. Okay, we'll see how each and every layer is going to do some specific function so that the data can be transmitted successfully from one terminal to another terminal. So these are all the OSI layers, starting from application layer to physical layer. The lowermost layer is a physical layer which deals with only transmission of raw bits. The application layer is the topmost layer. The front end users, they will be able to see only the application. The application layer only provides, for example, email or any application is provided in the application layer. It provides application with access to the network. And then the presentation layer. This presentation layer, in what format the data has to be transmitted among the network. So it determines the format which is used to exchange the data. And then session layer. This session layer helps to allow many applications to establish a connection, such as, examples for session layer. It can be name recognition or how security aspects can be implemented. These are all taken care by the session layer. Next, the transport layer. Transport layer helps to transmit the data without any error. So if the data are divided as chunks, it will repack the long messages. And then the network layer. The network layer addresses the message to proper location. The main function of the network layer is to convert the logical address into physical address. In order to find the shortest path, the network layer translates or converts the logical address into physical address. So any device will have, when it is connected in logical address, that will be whatever the information is transmitted to that particular destination, it reaches that receiver. Then the data link layer, which is above the physical layer, does packing as well as unpacking of the data packets. And finally, the physical layer deals with transmission of raw bits. So OSI layer plays a very major role for transmission between the signals. Next, what is a data packet? Data packets are the basic unit of information. We call it as a cell. Each cell or a data packet will contain a header information and the actual data, and then finally error checking, it will be appended. Error checking information will be appended at the end.
So what is an error checking information, sir?
Error checking information is we add parity bits at the end of the data. Okay, odd parity or even parity, or they may use some cyclic redundancy check, CRC they call it a cyclic redundancy check or longitudinal redundancy check. These error checking information will be used at the receiver to check whether the received data is error free or not. If at all any error is present, then the receiver can ask for retransmission of data, and so transmitter will again send the signal. So it will send a error information. If the error checking information calculates any error present in the data, it will request for the transmitter to resend the information. So
Sir,
in
this error checking information will be added by a transmitter to the data at a last sir, or in a
yes,
front?
it will be the error checking information will be added at the end. You have header, actual data, and then finally the error checking information. For example, using an XOR symbol, XOR gate, okay, XOR.
Yes, sir. Yes, sir.
So XOR symbols also can be used for error checking. They are called as gray codes. So when when XOR gate 10 gives 1 and 01 also gives 1, okay. So if the same data is going to be transmitted, 00 means there will not be any change, okay, and 11 also 0 only. So these types of simple parity checking or XOR information can be used for error checking. So if at all any symbol change is there, bit error change is there, it will detect. These types of error checking information will help to detect the errors. And when an error is detected, the receiver can request the transmitter to retransmit the signal. Okay, that is the use of this error checking information. Understood, boys? Hello?
Yes, sir.
Okay. Next, what is protocol? The protocol is derived from this Greek word protocolon, okay? So, which was a leaf of paper glued to a manuscript volume describing its contents. What should be followed? What are the rules need to be followed? Protocols are nothing but a special set of rules that nodes in a network need to follow when they communicate with each other. And these rules, they exist on all the OSI levels in the computer networks, and all the nodes, they must recognize and observe the procedure properly in order to send the signal or receive the signal properly. These rules need to be followed or governed. So what is protocol? How the sending computer and the receiving computer needs to follow some of the procedures. The transmitting terminal rules are it breaks the data into packets, add addressing information where to be sent, and also prepares the data for transmission. And similarly, the receiving terminal, the procedures need to follow is it takes the packet from the physical cable and it removes the packets of addressing information. Addressing information is related to which terminal it is going to be transmitted. And then it reassembles the data to form the actual packet, okay, actual data. It reassembles the data from the packets. So these are all the procedures they need to follow, both the transmitting and the receiving computer, in order for effectively communicating the data. Next, for two terminals, they want to communicate. They used some set of rules that is called as a protocols. Examples of some of the protocols are given: data net, computer networks, simple mail transfer protocol, file transfer protocol, transmission control protocol, internet protocol. These are all some of the examples of protocols which are used in computer communication.
Sir, what is meant by novel protocol, sir?
See, it is an internet protocol only, where, see, novel is nothing but a new protocol. Okay, we define it as a novel protocol, means it is a defined new protocol. They have given as this IPX and SPX is a novel protocol. Okay, a protocol which is defined to do some new function is called as a novel protocol. Okay. Hello.
Okay, sir.
A novel protocol means, see, something, if you design a procedure for some specific function, then it is called as a novel protocol. Okay. They have given such name, such as, if it is only for mail, if you want to transfer, it is mail transfer protocol. Similarly, for file transfer, it is file transfer protocol. TCP/IP, transmission control protocol, and internet protocol. Similarly, if they are going to use the same internet protocol for a specific reason, then they have used the name as novel protocol. Okay. And Ethernet, it is only an Ethernet, only physical bits will be transmitted in the physical layer protocol. Then it is called as a